Okay, good morning. So far, what we have seen over on it, how to design the FAR filter using our frequency sampling method. Okay, so let me recollect the steps. The first step, we have to have the windowing function values, and then second step, from a unit circle, we have to mark the points, the value of theta k by using the formula of an 360-degree n by n into k. On the third step, we have to find out the value of an h of k. On the fourth step, we have to find out the value of an h of n. Finally, we have to find out the value of an h of z, which is nothing but summation n is equal to 0 to n minus 1 h of n z bar minus n. Okay. So since already the given windowing function, the value e power minus j3 omega. So let me directly find out the points from the unit circle by using the formula of an theta k is equivalent to 360-degree divided by n into k. So that we have to substitute the value of k is equivalent to 0 to n minus 1. The value of n is equal to 7. So we have to start from 0 to 6. So let us start from over here, theta 1, theta 2, theta 3, theta 4, theta 5 and theta 6. Okay. So substitute the value of k is equivalent to 1, 2, 3, 4, 5 and 6 and use the value of n is equivalent to 7. So that we can able to get the value of theta 1 is equivalent to 51.42, theta 2 is equivalent to 102.8, theta 3 is equivalent to 154.26, theta 4 is equivalent to 205.68, theta 5 is equal to 25.71 and final theta 6 is equivalent to 308.52. Okay. The next step 2. We have to find out the value h of k. H of k is equivalent to e power minus j m minus 1 k into n. So for k is equal to 0 to 6, we have to find out. So e power minus j 6 pi by 7. So we'll be having the formula of n is equal to r. So we have the formula of n, h of n is equivalent to 1 by n, h of 0 plus summation n is equal to 1 to n minus 1 by 2 real part of h of k into e power j 2 pi k n by n. Okay. So let me complete it by substituting the limit over on it. So real part alone, we'll be having the value of n cos of value. Then after that, will be replacing the value of n is equivalent to 0, 1, 2, 3. So that we can able to get the value of n 4, 5 and 6. Okay. So we can able to find out the value h of 0 is equivalent to point minus 0.4, h of 1 is equivalent to 0.079, h of 2 is equivalent to 0.321, 3 is equivalent to 0.4286 and h of 4 is equivalent to h of 2, that is 0.321 and h of 5 is equivalent to h of 1, that is the value of 0.079, h of s 6 equal to h of 0 is equal to minus 0.114. So this is the way to complete our problem, or this is a way to design our FAR filter using our frequency sampling technique. Okay. The next step, the next problem is to be that we have to find out the coefficient of low pass FAR filter with n is equal to 15 and it has symmetric unit ripple response. It satisfies the following conditions. Okay. So the first step we have to, the given problem is to be that e power minus j n minus 1 by k into pi. The value of k is equal to 0, 1, 2, 3. We have the value to be 1 into e power value. Similarly, for k is equivalent to 4, we have the value of an 0.4 into e power j value. For the value of 5, 6, 7, the value is just given to be as an 0. So what we should do over on it? So we have to replace by n is equivalent to n minus 1. So we'll have a 14 pi divided by 15. Okay, because the value of n is equivalent to 15 given over on it. So we are replaced, we have found out the value of an h of k by substituting the value of an n is equivalent to 15. And then step 2, so since we are using an odd function value, so we can able to get the value h of n is equivalent to 1 by n, h of 0 plus summation n is equivalent to 1 minus 1 to n minus 1 by 2 to real part of h of k into e power minus j 2 pi n by capital N. Okay. So then after that, we have to replace the value of h of n is equal to 0 to 7 because since it is symmetrical response, so the h of 0 will be equal to 15, 1 will be equal to 14, 2 will be equal to 13, 3 will be equal to 12, it will be going on, 7 will be equal to 12. So by substituting all these values, we will be obtaining the value h of 0 is equivalent to minus 0.0141, h of 1 is equivalent to minus 0.0195. H of 2 is equivalent to 0.04, H of 3 is equivalent to 0.0122, 4 is equivalent to minus 0.0913, 5 is equivalent to minus 0.01809, 6 is equivalent to 313, 7 is equivalent to 0.52. So here pi is, we have to replace by 22 by 7 or we can use the value of 3.14. Okay. So this is the way to design our FIR filter using our frequency sampling technique. Okay. And then the next problem is to be that determine the coefficients of a linear phase FIR filter. This is a repeated university questions. of length m is equivalent to 15 has a symmetric unit impulse response and a frequency response that satisfies the condition 2 pi k by 15. Okay. So the same problem I think so. H of k is equivalent to when, where the limit varying from k is equal to 0 to 3 and 12 to 14, and in between the value there is 4 to 11, we will be getting the value is equal to 0. So we know that theta k is equivalent to n minus 1 by k into pi k, so 14 by 15 k, so theta k is equivalent to 1 for the value varying from 0 to 7. So then after that we will be replacing h of k e power minus j 14k by pi for the value of k is equal to 0, 1, 2, 3, and the value of 4 to 11 will be equivalent to e power minus j 4k minus 15. So since the value of n is equivalent to odd value, so we will be replacing h of n is equivalent to 1 by n with the value of h of 0 plus 2 of summation k is equivalent to 1 to n minus 1 by 2, real part of h of k e power j 2 pi nk by 15. So we know that if you are replacing real part value, cos of value, so e power minus j 14k by 15, e power j 2 pi k 15. So we can take common factor to be cos of 2 pi k. So what will happen? We will be getting of an 7 because 7 to the 14 minus n we will be getting. So then we will be spreading up a summation by substitute the value of k is equivalent to 1 to 3. So we'll have a 2 cos of 2 pi of 7 minus n plus 2 cos of 4 pi of 7 minus n plus 2 cos of 6 pi of 7 minus n by 15. So then after that substitute the value of n is equal to 0, 1, 2, 3, 4, 5, 6 and 7, so that we can able to obtain the value which is equivalent to, so since it's symmetrical response value, so we'll be replacing h of 0 is equal to 14, the value to be found to be 0.05, h of 1 and h of 3 will be same 0.04, when h of 4 and h of 10 is equivalent to 0.10782 and 12 will be equivalent to 0.0666 and 3 and 11 will be equivalent to 0.0365, 5 and 9 will be 0.034, 6 and 8 will be 0.3188 and 7 will be equivalent to 0.466. Okay, so this is the way to find out the value or design our FIR filter using a frequency sampling technique. Okay, so this is to be a little bit different problem by giving the value of an sampling frequency and the cutoff frequencies. So we'll have a 8000 hertz, 1000 hertz and 3000 hertz. Determine the filter coefficients for n is equivalent to 7 and the given specification is to be that band pass filter. So omega C1 is equivalent to 2 pi fc1 into t. So t is nothing but an 1 by f. So we'll be replacing the value and we can able to find out the value to be pi by 4. Similarly, for by supplying the cutoff second frequencies, by applying the value, so we will be able to find the value 3 pi by 4. So what we can able to obtain that k is equivalent to 0 to 6, the value of which is equivalent to hd of e power j omega. So h of k is equivalent to 0 for the value of k is equal to 0 and 3, and for 1 for k is equivalent to 1 and 2. So we replace the value of theta k is equivalent to n minus 1 by n pi k. So we'll be having 6 pi by 7. So j pi by 6. So since the filter coefficients are given by over that 1 by n of h of 0 plus 2 summation k is equivalent to 1 to n minus 1 by 2 to real part of h of k e power j 2 pi k n by n. Okay. So real part of e power j 6 pi k. So we can take the common factor to be cos 2 pi by 7. So we can able to get the value of 3 minus n. Now we substitute our limit. So which is equivalent to only things to be that 2 cos of 2 pi by 7, 3 minus n and plus cos of 4 pi by 7, 3 minus n. Okay. So when you are when you are substituting the value of n 0, 1, 2, 3, so that we can able to obtain h of 0 is equal to h of 6, which is equivalent to minus 0.07928, h of 1 is equal to h of 5 is equivalent to minus 0.321, and h of 2 and h of 4 will be the same, which is equivalent to minus 0.456, and finally h of 3 is equivalent to 0.57. Okay, so that what we can able to obtain that. So this is the way generally we have to use of it, finding the value of an theta of k, and then we have to find out the value of h of k, and then finally we have to be finding the value of an filter coefficient. Actually the formula will be different for the case of an n is odd and even. Okay, so this is the way to find out of a or we'll be designing a linear phase FIR filter. Okay, so these are the home problems. There is a design a linear phase FIR high pass filter using Hamming window with the cutoff frequency is given, and similarly we can able to design FIR low pass filter with cutoff frequency and sampling frequency using Fourier series method. And the thing is to be rectangular windowing technique other than low pass filter with the cutoff frequencies and working on sampling frequencies and the impulses to be 7. So that overall third unit gets over. Thing is to be that, so we are recollected that what are the realization structures of an FIR filter, and then how to design our will be having of an symmetric and antisymmetric FIR filters. And the third thing, how to design our FIR filter using a Fourier series method and a windowing method. In windowing method, particularly we have seen about an Hanning window, Hamming window, and rectangular window. Finally, how to design a FIR filter using a frequency sampling technique. Okay. Uh, Thank you all.